So the scatter plot below compares the number of bags of popcorn and the number of soda sold at each performance of the circus over 1 week. Which conclusion can be drawn from the scatter plot? Okay, negative. First of all, let's analyze this. The correlation here is positive, so negative correlation is not right. All right, there's a positive correlation between this. Yes, there's no correlation. That's not true at all. Look, I see a pattern. Buying popcorn causes people to buy soda. Buying popcorn causes people to buy soda. I should go and ask my son, right? No, buying popcorn just means that you buy popcorn. They could buy water, they could buy whatever. So then, the obvious choice is that there is a positive correlation between the popcorn and the sodas. As one increases, the other increases as well. Good. Next question. All right. So this is the table. You read the question, right? The averages and their averages in the math class. If a linear model is applied, okay. If a linear model is applied to the data, which statement best describes the correlation coefficient? Sure. First of all, let me explain to you. This little box right here, when I was trying to edit it, all the negatives became a box. So this is a negative. Now the other one, 91. All right, and now they want a linear model, so let's go calculate linear regression. I don't need to store anything because I'm not being asked any more questions. So the correlation coefficient is 0.92. So boom, 92.4 if you want to. Now we know that it is close to 1. So number 2 is the answer. At Mountain Lakes High School, the mathematics and physics course of 9 students were completed as shown in the table below. State the correlation coefficient to the nearest 100 for the line of best fit for this data. Explain what the correlation coefficient means with regards to the context of this situation. Alright, so I'll start putting this in your table. Do it. Hopefully you have a calculator and you haven't been relying on me. I'm gonna actually plot the points. I need to see what the behavior is, so let me adjust the window. Minimum value, so let's start with 30. Maximum value, let's say 100. 40. 100. So it looks like, and it apparently doesn't have a exponential function, an exponential behavior. It seems like a linear model will actually be the best model. So then let's do that. So now we're gonna go to stat. We're gonna calculate the linear regression. At this point, you should understand what I'm talking about. All right, I'm gonna store it just for fun. Okay, so that's my linear regression. So we're gonna do y equals 0.8098x, okay, plus 15.185. R is 0.9215, just for the sake of having the information. And now let's see what they were asking, because I forgot about it. Okay, so state the correlation coefficient. Okay, I got it. And explain. Okay, explain what the correlation coefficient means with regards to the context of the situation. What do you think it means? Okay, it means that there is a strong, okay, strong positive correlation or a strong relationship, a strong positive between a student's math math or mathematics and physics scores. That's it. That's all it means. Okay? Correlation coefficient. There's a strong relationship between the math and the physics scores of students. However you want to say it. All right. Let's move on to the next question. Oh, okay. It says use the data below to write the regression equation below for the raw test scores based on the hours tutor, round all values to the nearest hundredth. Okay, so we're talking about the test scores. So let's do it. What you're gonna do is you're gonna put this is your x, this is your y. We spoke about residuals a while back ago. We're not using it yet, but we know what it means. All right, so what will be the equation? Use your calculator and calculate the equation. All right, and we're talking about linear, so we know what we gotta. So stats, calculate linear regression. I'm not gonna store it. Okay, so that's your linear regression. Okay, so that's one part of it. Let's go into the second part of this. This is a 4-point question. All right, so what it says, create a residual plot on the axis below using the residual scores in the table. Sure, why not? All right, let's take a look at the test scores. Okay, I'm sorry, at the table. So we got it right there. Take a look at it, write it down so you don't be missing it. And now let's move on. Okay, so let's see how I do this. Okay, this should be enough. So when x is 1, the residual, okay, which is the actual minus the predicted, when x is 1, the residual is 1.3. So 1.3 should be around here. Okay. When x is 2, all right, when x is 2, the residual is 1.9, so it's around close to 2. When x is 3, the residual is negative 6.4. When x is 3, the residual is negative 6.4. It should be around here. When x is 4, the residual is negative 0.7. When x is 4, the residual is negative 0.7, so it's around here. Okay. When x is 5, the residual is 2. So when x is 5, the residual is 2. When x is 6, the residual is 6.6. So 6.6 is around here. Okay. And when x is 7, the residual is negative 4.7. When x is 7, the residual is negative 4.7. So around here. Okay. And that basically is your residual graph. It's nothing fancy. It was just graphing points, okay? Nothing like, oh, let's create something, you know, rocket science. Now let's have a look at the rest of the question. It says, based on the residual plot, state whether the equation is a good fit for the data and justify your answer. Okay, so let's take a look at the graph. Look, let me give you an example. Let me use this. I don't know if I said it before, but I'm gonna say it right now. You have a residual graph. Let me use the ruler. Okay, there are different ways of doing this. Let me give you different examples so you can have an idea, because I don't remember if I did this. Okay, and you should be copying this down just in case. All right, let's say we have a residual going like this. Okay, do the points seem to have a pattern? No, right? So that's a good thing. Okay, here. Do the points seem to have a pattern? A pattern. Yeah, I could see a pattern right here. Okay. Here I don't see a pattern. And a pattern I'm talking about like up and down, like a curve. No. Look at this. Do the points seem to have a pattern right there? I believe they do. So, if the points have a pattern, and we're talking about residual, okay, what is the residual? Is on the line that best fit is the difference between, okay, the actual value, the value that you actually have, and the predicted value. Okay, what the line predicts. This is what you call a residual. Sometimes you could call it the error. The error in, why in the world? So, and I still don't have an eraser. I need to find one. The error between, okay, or the error in the difference between the actual and the predicted. How much off was the predicted value from the actual? Okay, got it? All right then, so that's what it means. If you see a, wow, and I threw it out. If you see a pattern here in the residual plot, then no good, no Gucci, no good. If there is no pattern, then good. Okay? Pattern means no good. That means that the line is not a good fit. Pattern, no good. No good fit. Okay? The model is not a perfect, is not a good fit. No pattern, good fit. All right? So then, now let's answer this question. Based on the residual plot, state whether the line is a good fit for your data. So, what am I gonna answer? Based on the residual plot, the equation is a good fit for the data because the residual values are scattered without a pattern. Okay, because I'm tired of writing. Because what did I say? I forgot. Because the residual values are scattered, okay, without a pattern. Go B. Without a pattern. Okay. And R, oh yeah, and they have to also be like fairly distributed up above the X and below. So I'm gonna write this down. This is gonna help me with my explanation, of course. What were you thinking, Becker? All right, and are evenly distributed above and below the x-axis. So the values evenly, okay, distributed above seriously, what I gotta do for 4 miserable points, right? Well, okay, so that's what it is. That was the answer. All right, so let's move on to the next problem. 40, okay. All right, so let's see this problem. Which statistic would indicate that a linear function would not be a good fit? Okay, would not be a good fit to model a data set or data set. Well, the correlation coefficient here is negative 0.93. That means 93%. This is a good fit. Oh my God, a perfect fit. Now, these are graphs of residuals. Just in case you didn't notice, they will always look like this on the regions. And between this and this one, remember what the residual plot determines whether the data is a good fit or not. If it does have a pattern, remember what we did last time? If it has a pattern, then it's no good. So this is no good because I could see the pattern right here. Look like a U. Now on the other hand, this one, it doesn't have a visible pattern, and the values are evenly scattered above and below the x-axis. So that means, oh wait, that means that this is a good fit as well. So this is a good fit, this is a good perfect fit, this is a perfect, no, close to -1, so it's a good fit, but this one is no good. So guess what? The question is asking which would not be a good fit. So let me see, choice 1, choice 2, choice 3 is your answer right here. This is not a good fit to model the data. All right, the next one. It says, after performing analysis on a set of data, Jackie examined the scatter plot of the residual values for each analysis. Which scatter plot indicates the best fit? Which one is the best fit? Which one do you think? I'm going to show you all 4 right here. Boom, 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 boom. Okay, right here. There you have them. Is this a good fit? No. Is this a good fit? The points are not evenly scattered, so no, this is not a good fit either. Choice 2 is not a good fit. Okay then. So then let's take a look at the other 2. Maybe. Okay, maybe could be a good fit. Oh gosh, look at this one. The points are not evenly distributed, and I could see a pattern right here going up and then going down. So our choice is choice number 3. Okay, 1, 2, 3. Choice number 3 is a good fit for the data. All right, let's move on to the next question. Oh gosh, no, please, no graphing. Let's read what it says. It says, the table below represents the residuals for a line of best fit. So these are the x values, these are the residual values. Remember, the residual is the actual value minus the predicted. And these are. So what do they want? Plot these residuals. All right, I'll plot them. Or actually, you will plot them. So what do I have? All right, so this is 0, 0, okay? Now, it's a good idea on the regions to write down the numbers, your scale. So the numbers go from here, look, the numbers go, it's 2, 3, 3, 4, 6, 7, okay. So I could do a scale from 0 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And boom, it's a good idea to write them down. I'm not gonna write them down because I'm lazy. but you're the student, so you have to. Okay, 2 comma 2, 2 comma 2, right here. 3 comma 1, 3 comma 1, right here. 3 comma negative 1, okay, 3 comma negative 1. 4 comma negative 2, 4 comma negative 2. 6 comma negative 3. So this is 4, this is 5, this is 6. 6 comma negative 3. 7 comma negative 2. 7 comma negative 2. So 7 comma negative 2. 8 comma negative 1. 9 comma 2. 9 comma 0. Whoops, 9 comma 0, sorry. And guess what? I have an eraser. Okay, 9 comma 0 and 10 comma 3. 10 comma 1, 2, 3, right here. So that's my data. Now the question. The question says, using the plot, assess the fit of the line of these residuals and justify your answer. So I read the question. I'm gonna put it later for you so you can read it, but look at this. Is this a good fit? Does it look like it's a good fit? We know about residuals. If they have a pattern, no good, no bueno. So then, malo hombres. Let's justify our response. So the line is a poor fit because, okay, the line is a poor fit because the residuals form a pattern. And you could say that the values are not evenly scattered above and below, or are not evenly distributed above and below the x-axis. Okay? Good. Let's move on. Okay. So it says, the residual plot from two different sets of bivariate data are graphed below. Bivariate means that there are two variables, okay? That's what it means. All right. So now, these are the plots, and let's see what it says. Explain, using evidence from graph A and graph B, which graph indicates that the model for the data is a good fit. All right. Right away, which do you think is a good fit? Got it? Okay, so here I could see a pattern and the points are not evenly distributed above and below. So this is the better fit. So then graph A all right, so this is a cool explanation. I'm supposed to justify my answer, right? Explain, it says using evidence from both graphs. So it doesn't say from one graph. So okay, graph A is a good fit because it does not have a clear pattern, and we saw it right here. It does not have a clear pattern. Whereas graph B does. Graph B has a pattern, and you could actually write it down. Whereas graph B does have a pattern, okay? It goes up and then it goes down, and the points are not evenly distributed above and below the x-axis. Cool? All right. Here we go with the next topic. Expressions and equations. Dependent and independent variable. All right. So it says the formula for the surface area of a right rectangular prism A is, and we have the formula right here, where L, W, and H represents the length, width, and height respectively, of course. Which term of this formula is not dependent on the height? Okay, which of the terms in this formula is not dependent on the height? Let's take a wild guess. Or actually, let's analyze this. Which of these does not depend on the height? If you chose choice number 2, you are correct. choice number 2, 2LW, it does not depend on the height. Okay, the area is equal to all this, which includes the height. Then 2HW has height, 2LH has height. This one does not depend on the height. Boom. Okay, 46. To watch varsity basketball game, spectators must buy a ticket at the door. The cost of an adult ticket is $3 and the cost of a student ticket is $1.50. If the number of adult tickets sold is represented by A and the number of tickets sold represented by students' tickets sold represented by S. Okay, so adult is A and student is S. Which expression represents the amount of money collected at the door from the ticket sales? All right, let's analyze this. Ticket sales. What do I know? The adult ticket is $3, so I'm gonna have $3 for the adult people. Then I am going to have the student tickets cost $1.50. So $1.50, 1.5 or 1.50, however you want to call it, S. So I know that it says which expression represents the amount of money collected at the door from the ticket sales, from all the ticket sales. That means from the adults and the students. So what do I want to do? Do I want to multiply the number of adult tickets sold times the number of student tickets sold? No. If I sell 3 tickets to the adults, I'm gonna have $9. If I sell 3 tickets to the students, I'm gonna have $4.50. Just so how much money do I have? I have $13.50. Oh, okay, so you gotta add them. Yes, you gotta add them. Therefore, your correct choice is choice number 4. Okay, here they're multiplying the adult times the students. You don't do that. Here they are saying that all tickets cost $4.50, and you just have to add all the adults and all the tickets. No. Here it says that you're gonna multiply them. You're not gonna multiply them. So you're gonna add them, and bada bing, bada boom, bada bam. That's your explanation. Okay, next question. 47. It says an expression of the 5th degree is written with a leading coefficient of 7 and a constant of 6. Which expression is correctly written for these conditions? First of all, a leading coefficient is the coefficient that multiplies the variable to the maximum exponent. So for example, this is 6x to the 5th power. Okay, let's see if you can see better. I'm gonna I can do a close up, although it's not really that clear. This is a 5, this is a 6, this is a 7, this is a 5. Okay, so an expression of the 5th degree is written. The only expressions to the 5th degree are this one and this one. Okay, with a leading coefficient of 7. Okay, that's it. I found my answer. And a constant of 6. The constant is usually the number that doesn't have the variable. Right there. Alright? This one doesn't have the coefficient being 7. So boom. Alright? Gucci. Next question. Hopefully you understood. If not, then you have to rewind it and look at it again. Alright. 49. It says Andy has $310 in his account. Okay, each week W, he withdraws $30 from his expenses. Okay, so every week from the $310 he's gonna withdraw, he's gonna take away. Which expression could be used if he wanted to find how much money he had left after 8 weeks? Sure, so he does have $310. In each week he's gonna withdraw $30. So here, if I was to remember, weeks is W. So here, if W was 1, then actually 8 times 1 is 8. So it's not 30. So this is not going to give you, okay, a prediction of how much money he would have after 8 weeks. This does not represent 8 weeks. Okay, this is just the amount that is going to be decreased for every week. So week 1, $8. Week 2, $16. Doesn't work. It has to be 30. All right. Choice number 2, $280. Let's take a look at the first week. Or, you know what? At the beginning, he has $310. So at 0 weeks, he has $310. All right? So if here, week is 0. At 0 weeks, 0 minus 1 is negative 1. Yes? 0 minus 1 is negative 1. Oh man, I hope I'm giving a good explanation because I'm not even writing anything. So let's say at 0 weeks, he's supposed to have $310. So 0 minus 1 is negative 1. 30 times negative 1 is negative 30. 280 minus 30 is 250. That's not $310. So this cannot be used to predict. Let's try this one. The first week. Sorry, at 0 weeks. 310 times 0 is 0. Minus 30 is negative 30. That's not how much money he will have left. Remember, at 0 weeks, he's supposed to have $310. Let's try here. At 0 weeks, it will have 0 minus 1 is negative 1. Negative 30 times negative 1 is positive 30. Positive 30. 280 plus 30 is 310. Okay. Now let's confirm by using how much money he will have after the first week. So at the first week, so week is W is 1. So 1 minus 1 is 0. Negative 30 times 0 is 0. 280 minus 0 is 280. And it is true because after the first week, he withdraws $30. He's going to have $280. At 0 weeks, he will have $310. And if we continue, we are going to find out that this is the choice that makes the most sense. Now, you might be confused. You might say, yeah, but it says that he had $310. Don't I have to start with $310 and then subtract the $30 that he's going to do per week? Yes, you could do that. But unfortunately, you have to go with what the choices tell you. You understand? All right, good then. Let's move on. 40, the next one. Okay. When multiplying polynomials for a math assignment, Pat found the product to be blah, blah, blah. So you read it. He then had to state the leading coefficient of this polynomial. Pat wrote down -4. Do you agree with Pat's answer? Explain your reasoning. Okay, so Pat wrote that -4 is the leading coefficient. What do we know about the leading coefficient? The leading coefficient is the number that multiplies the variable to the highest exponent. Okay, so then to you, let's rearrange this polynomial. Okay, so how do I rearrange it? Easy. So -2x to the third, okay, highest exponent, plus 8x squared, okay, minus 4x plus 5. Oh, okay. Now it's easier to see what the leading coefficient is. So to answer the question, I disagree with Pat because with Pat because the leading coefficient, okay, the leading coefficient okay is the coefficient of the term with the highest exponent, period. In this case, -2. And there goes your complete explanation. highest. Sorry. Boom. Ha 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 ha. Okay, let's answer the next question. Connor wants to burn 250 calories while exercising for 45 minutes at the gym on the treadmill. He can burn 6 calories per minute on the stationary bike. He can burn 5 calories per minute. If T represents, on the stationary bike, he can burn 5 calories per minute. If T represents the number of minutes on the treadmill and B represents the number of minutes on the stationary bike, which expression represents the number of calories that Connor can burn on the stationary bike? Okay, 60 number of minutes on the treadmill. B represents the number of minutes in the stationary bike. So B on the stationary bike, so that will be that it can burn 5 calories per minute. So 5 calories per minute. Okay, so 5B on the treadmill is 60. He can burn 6 calories on the stationary bike. He can burn 5 calories per minute. 5 calories per minute. The stationary bike. 5B. Oh my God, dummy. I got it. Choice number 2. All this for that. Okay. Okay. What is the value of x in the equation? And we have this. So there are different ways of solving the equation. We're gonna do it algebraically, and then I'm gonna show you how to do it on the calculator. All right. So first things first. Let's ask ourselves the following questions. There are, remember the 5 golden rules? Okay, the first rule is, do I have distributive property? The second rule is, do I have fractions? The third rule is, do I have like terms on the same side? The fourth rule is, do I have variables on both sides? Then use the additive inverse, and then use the multiplicative inverse or reciprocal. So those are the 6 golden rules that we always have to follow in order to solve equations, linear equations. So let's see. Do I have distributive property? No, right? Okay, so no. I have to be drinking water, otherwise I start coughing. Okay, so do I have fractions? Yes. So what does it say? If I have fractions, the golden rules, if you watch the episode, it says find the least common denominator, or the least common multiple, or minimum common multiple, whatever you want to call it, and multiply the whole equation by that. So I see that the common denominator here is 6, so I'm going to multiply by 6 over 1, or just 6. See that? Okay then. So what happens when I multiply by 6? Well, let's see. You could multiply by the top and divide by the bottom, or divide by the bottom and multiply by the top. It's really the same thing. I am going to be lazy, and I'm just going to divide by the bottom and multiply by the top. So 6 divided by 3 is 2. 2 times x minus 2 is what? 2x minus 4. I'm multiplying this by 2. Remember, 6 divided by 3 is 2, and then I multiply this. Now 6 plus, of course, plus 6 divided by 6 is 1 times 1, 1. And now on the other side, 6 divided by 6 is 1 times 5, 5. Now let me show you what I mean by saying that dividing and then multiplying is the same thing as multiplying and then dividing. Look, 6 times 5 is 30. 30 divided by 6 is 5. But it's easier when you divide because you get a smaller number. Got it? Alright, so fractions, yes, and I took care of them. Do I have like terms on the same side of the equation? That means here. Yes, I do. What are the like terms? Negative 4 and 1. So negative 4 plus 1 is negative 3. So 2x minus 3 equals 5. Do I have variables on both sides? No, I don't see variables on both sides. Now, additive inverse. Is there a number that is adding or subtracting the variable to the variable? Yes, negative 3. So I'm going to use the additive inverse of negative 3, which is positive 3. And now write down whatever you have left. So 2x, okay, these 3 canceled out. 5 plus 3 is 8. So yes. Last but not least, multiplicative inverse. Is there a number that is multiplying or dividing the variable? Yes. The 2 is multiplying x. So I'm going to use the multiplicative inverse of 2, which is 1 over 2. I know. You could just say, hey, can you just divide by 2 and that's it? Yes, you can. Alright, so the idea behind the multiplicative inverse is to cancel out this. Remember, this is a 2 over 1, so they also cancel. So that leaves you with x. X times 1 is 8. 8 times 1 is 8, divided by 2 is 4. So x equals 4. So that's the value of x. So then we go to our choices and we say choice number 4 is the right choice. All right. Okay then. Let's move on to the next. Oh wait, I said I was going to show you how to do it on the calculator. Sure. So you turn on the calculator. Clear, right? Press the key that reads math. And go all the way to the bottom and you see Numeric Solver. This is only for the TI-84 plus C or the TI-84 plus CE. The other one does not do it. The other one you have to manipulate it, which I don't remember how to do it. Alright, so Numeric Solver. This is one side of the equation and this is the other. So I'm going to type exactly what I see on the calculator. So what I'm going to do is I'm going to press alpha y equals to tap into the fractional menu. So numerator over denominator, press enter. And now what am I going to write on top? X minus 2. In the bottom, 3. Then move over. Alright, what else? Plus 1 6. So plus, okay, again, alpha y equals enter over 6. That's the end of my the left hand side. Now I'm gonna go to the right hand side and I'm gonna put 5 over 6. So alpha y equals boom 5 over 6. Okay, and that's it. Now if you have the TI-84 plus C, you press graph and then you press alpha enter. If you have this calculator, the TI-84 plus CE, you press graph once because it says solve and then you press it again for it can actually solve it for you. Now notice something. It's giving you an answer of 3.9999999. Every time you see this type of answer, just round it to the nearest integer. So in other words, 3.9999999 turns into 4.